In the dead of night, in a remote Siberian village, a mysterious glow appeared in the sky, followed by a deafening explosion that flattened thousands of trees over an area larger than a city. What exactly happened on that fateful day in 1908 remains one of the greatest unsolved mysteries in history. Known as the Tunguska Event, it wasn't just a natural disaster. It was an enigma that baffled scientists for decades. A massive explosion, equivalent to 10 to 15 megatons of TNT, devastated a forest the size of Manhattan, yet no impact crater was ever found. How could such a cataclysm occur without leaving a traditional mark? Witnesses described an intense flash, hotter than the sun, that turned night into day. People hundreds of kilometers away heard a thunderous roar that shook the ground. Windows shattered and animals fled in panic. Yet despite this chaos, the event left no large meteorite fragments behind. Over the years, countless theories have tried to explain what exploded in the sky over Tunguska. Some believed it was a comet fragment burning up in the atmosphere. Others suggested a meteorite exploding mid-air. There were even wild speculations about secret weapons tests or extraterrestrial spacecraft crashes. But the truth is far more fascinating and strange than any fiction. The most accepted explanation today is that a stony meteoroid, about 50 to 60 meters wide, entered Earth's atmosphere at tremendous speed. Friction and pressure caused it to explode roughly 5 to 10 kilometers above the ground. This explosion released energy equivalent to hundreds of Hiroshima atomic bombs. Yet what makes Tunguska extraordinary isn't just the scale of destruction, but the almost surgical precision with which the blast unfolded. The shockwave radiated outwards, knocking down trees in a radial pattern, but strangely, trees in the immediate center of the blast remained standing, stripped of their branches but upright. Scientists refer to this as the butterfly pattern, a signature almost impossible to replicate in conventional explosions. Adding to the mystery, some survivors reported seeing strange glowing objects in the sky days before the event, suggesting the meteoroid might have fragmented or been accompanied by other celestial bodies. In 1927, Leonid Kulik, a Russian mineralogist, led the first official expedition to the site. Despite harsh conditions, Kulik's team documented the flattened forest and collected eyewitness reports. Kulik's passion turned into obsession as he scoured for fragments that might reveal the meteoroid's origin. However, decades passed with no definitive findings. It wasn't until modern aerial photography and satellite imagery that the unique damage pattern was fully appreciated. The event challenged existing knowledge about atmospheric explosions and meteoroid behavior. Intriguingly, the Tunguska explosion could have had catastrophic global consequences if it had occurred over a populated area. Some experts believe it might have triggered a nuclear winter, affecting climate and ecosystems worldwide. Even today, new research delves into ice core samples and tree rings to uncover subtle environmental clues from 1908. These data provide insights into the atmospheric impact and help scientists understand the risks posed by near-Earth objects. While we may never fully grasp every detail of the Tunguska event, its legacy continues to inspire science and imagination. It reminds us how fragile our planet is, perched beneath an unpredictable sky. And as space agencies develop new technologies to detect and deflect dangerous asteroids, the shadow of Tunguska serves as a haunting warning, a cosmic whisper of destruction that arrived without warning, reshaping history forever.